Hey, this is Miss Lee again. In this video I wanted to talk about factoring using the difference of two perfect squares. This is one of the easiest ways to factor. Pretty much it's whatever the first term is, if it is a perfect square and you are subtracting it from another perfect square, you will always end up in this format. So knowing your perfect squares would be a really good prerequisite. I'll start with some easy ones, and I'm going to go ahead and start writing them in a certain form so you can see what I mean. So this x squared is really a base x that is being squared, and it's being subtracted from a base 2 that's being squared. Now some people like to put parentheses here. This isn't necessary for simple problems like this once you get the hang of it, but sometimes in these more complicated problems it tends to be very well received. So once I know what the base is, essentially I'm square rooting it. Once I know what those bases are, now I just need to put it in this format. And the format is the exact same. I add one and I subtract one of each. So I could start off by putting the parentheses here. I can put a plus and I can put a minus, because no matter what, that's going to be the format. Whatever my base is here, so my base was x, so I write the x in front, and then what my base is for the second one, I write them back. So I have x plus 2 and x minus 2. And a really wonderful thing would happen in your brain if you weren't sure and weren't really getting this into why this is working. If you distributed this out, what you'll notice is x times x is x squared. That's where this is coming from. X times a negative 2 is a negative 2x. And I will write that off the side. I'd end up with a negative 2x. So I have an x squared, a negative 2x, and then if I do this, 2 times x, right? I've distributed the first one to both of those two to get those, and I distribute the second one to both of these. So 2 times x is 2x, positive 2x, and then a 2 times a negative 2 gives me the negative 4. Well, these two terms together, if I add them up, I will zoom in there. That's kind of awkward. But if I add a negative 2x and a positive x together, I get 0. Because they cancel each other out. And that's the concept of a difference of two perfect squares. If I end up subtracting them, those middle terms cancel out. So one of the best things if you're struggling on the difference of two perfect squares is to just go from this step to this step. Go from having the factored form to distributing it out or foiling it out and getting this form. You will see every single time that those middle terms cancel out, so it will help you realize when you're trying to factor what's really happening. So again, my base of the first one is x. So I have this x squared minus, I'll do that, this 4 squared. I want to double check 4 times, I don't know why I wrote 4 there. This is square. So 4 squared would give me 16. So that means that my end result is x plus 4 and x minus 4. Now I'm going to do the next one like you would normally do it for a basic problem like this. I would notice that x squared is a perfect square of x, and that 144 is a perfect square. It is 12 times 12. So because I know that, I would just go ahead and write that I have x plus 12 and x minus 12. Remember, it's the square roots of both of those things. So usually the difference of two perfect squares is that easy to write down. There's not generally a lot of work to show. So now on this next one, it'll be really useful for me to really break down what is my base that's being squared. So I'm going to go ahead and pre-fill out some of that. So is 16 a perfect square? Yes, it's 4 times 4, so I know I have a 4 in here. And I also need to get this x squared, so I need a base of 4x. And if I had 4x times 4x, I would get a 16x squared, so I know that's my base. The base over here is 5. So that means when I go to write my answer, I have 4x, because the base of the first one, plus 5, because that's the base of the second one, and then I'm going to multiply that by the base of the first one, so 4x, that didn't change, and then a minus, and then 5, because that's the base of the second one. And this one is going to have the exact same form. So let me go ahead and circle some of my answers. This one's going to have the exact same format. I'm going to have something with a plus and something with a minus. And that will be my answer. I just got to figure out what my base is. So my base for this, square root of 9 is 3, and the square root of x squared is x. So because that's my first base, I know it's going to go in here. And then the second one, the square root of 4 is 2, and the square root of y squared is y. So I have a 2y and a 2y. That would be my answer. 3x plus 2y and 3x minus 2y. So for this last one, or second to last one I should say, I have a square root of 49 is 7. The square root of m to the 4 is an m squared. Because the property is if I have a power raised to a power, I would multiply. So 2 times 2 is 4. Then I subtract, and the square root of 81 is 9. So I know I have a 9n, and that quantity, if I square it, would give me 81n squared. So then my answer would be 7m squared plus the 9n, and then the 7m squared minus 9n, if I could fit it. Yay. And that would be my answer. So I picked this next one because I want to show you that you have to be careful. Just because you got an answer here doesn't mean you're actually done. So first thing I want to do is break this down and start realizing what is my base. Well, the rule that we just set up here was if I have a power to a power, I multiply. And I have an exponents video if you want to watch that one. So I need some power that when I multiply it by 2 would give me an 8. So then the opposite of that, working backwards, is I need to divide 8 by 2, which would give me a 4. So I have m4 and then n4. And if I double check, 4 times 2 is 8, so that would give me m8. Now, let's go this way with it. I would have something plus something, something minus something. Remember, that's my format. So the first thing was M4, and the second thing was N4. Well, this first one has a plus, and it's not a cubed, or I can't divide them by 3, and I can get into another video with that, but this is not factorable anymore. However, I could write M4 and N4 as a power of 2. So let me break this one out. I'm going to kind of bring this down because I don't want to forget it, and it's really easy to forget things. So I'm just going to write it as is, M4 plus N4. But I want to think about this as M squared to the power of 2 minus N squared to the power of 2. So this I didn't change, and I'm updating this like if I had started with it, could I continue to factor that? And if I notice, 2 times 2 is 4, so I can kind of keep reducing this. This is a difference, it's a subtraction of 2 things that could be written as perfect squares. So I know my answer choice is going to be something with a plus and something with a minus. So then I get M squared and there's a plus, and those aren't cubes, and they're not divisible by 3, so I know that that's the furthest it goes. But if you notice, this is a difference, and those are divisible by 2, so I know it could be a perfect square, potentially. So M4 plus N4, M squared plus N squared, and this is going to break out into one with a plus, one with a minus. The square root of M squared is M, and the square root of N squared is N. So that's what we ended up with, and that would be our final answer, because the difference that's left over, none of those are cubes, so they're none powers of 3, and that one that is a difference doesn't have anything that I could take the square root of. So that would be my end answer. So I did this problem just to make sure to emphasize too, you need to keep checking to make sure that you have completely factored the problem. So I hope that this has helped you to learn the difference of 2 perfect squares. If you seem to have a problem with them, remember I said to go through and go backwards and take an answer and keep foiling it to see that there's a difference there. Also, you could help yourself by practicing just square rooting or just knowing what perfect squares are, because that could be another thing that's holding you back. Besides that, I hope you have a great day. Remember to like, share, and subscribe. Bye.